All right, let's go ahead and get started. Hi, everybody. How are you all doing today? Did you enjoy the snowstorm? By the way, how many Monday classes? Was yesterday the first day Monday classes were canceled for Georgetown? So annoying. I got an email from the provost saying, "Oh no, Monday classes are canceled. We're going to have to make them up." And I'm like, "What about the Tuesday, Thursday classes? We've missed 2 of already." So anyway, okay. Normally we talk about what we did last time. This time, let's talk about what's going to happen next time. What's going to happen next time? We're going to have a midterm exam. All right, before we get started, I want to make clear the notes are available through Blackboard. You already found those? The only topics I will write questions about are things that are on that list. I will not pull things out of there. There's plenty of tricky stuff in that list that I can do fine with that. Any questions? No? Okay, good luck. Oh, there are questions, yes. You can go ahead, ask questions. No, this is really, I saved time for questions today. Uh-huh. Okay, yes. Can you read the line to me? And I'll tell you. Other questions while she's looking that up. Sir. Okay, so on the second midterm, there was a problem with functions that looked very confusing to you. It had ampersands floating around, making you crazy. We didn't get to that. And so I didn't include that particular topic on this midterm. We will cover it today. If you'd like, I can go back and rewrite the midterm to include that. No? Doesn't seem popular? Okay, so we will get to that today. We're a little bit behind because of the snow days, but not so far that I felt obligated to try and make it up. So we'll cover that today. And it won't be on the exam. Yes, your question to go back to it. Okay, so the question is about reading a string using getLine, then getting just the first word out of that string. And the question of that is, if you read something with getLine and it's a whole sentence, what does getLine get? It gets the full sentence, right? And has all the words in there. Say you wanted to find and extract the first word out of that sentence. How would you do that? Okay, so the answer is you would have to, and you're right, the answer was if you wanted to find the first word out of a sentence string is you have to search until you find the first space. How do you search until you find the first space? You have a for loop, you start at 0, and you just keep going until the .at method shows that it's a space. Once you've done that, how do you extract just that string out of the big string? Some people obtain enlightenment in different ways, so you have to use substring. But you already know where it starts because it starts at 0, and you know where it ends because you found the space. So you just say string equals substring with the right numbers in there. No, you have to have a for loop that it won't automatically quit. Okay, then do a while something dot at whatever is not a space. You can use a while loop for that case. No, instead of a for loop. So sorry, I misled you by saying for loop. In this case, if you want to find the place at the first space out of a string, is it a for loop or a while loop? Do we know where the space is? It's a while loop, and you say while the thing that you're at is not a space, go on to add one, yeah, and that'll work to cover that. Yep. If there are spaces in the front, it causes problems. You can if I wanted to make it very complex, I would say skip all leading spaces until you find something that's not a space, and then find the space after that. Yes. Trust me, I can make the complexity of these problems arbitrarily complex if I want. It's just a matter of how badly I want to reduce you to a pile of sobbing tears, right? I mean, I can make the questions arbitrarily hard, but you have examples of the questions I write. I've been giving handouts, right? I gave you the midterm before. So you see the kind of things that I put on there. Those are not trick questions in the sense that I gave you a bunch of easy questions with the intention of giving you harder questions to get you to break your will to live. It is not my goal that come the withdraw deadline that every single one of you withdraw from this class so I don't have to do any more work, okay? So The exam questions are going to be similar to the handouts that I've given you, similar to the midterm that I gave you, the sample midterm that I gave you. Okay? Does that sound fair? And it only covers the topics that I put on there. That being said, you got to know your material, right? You have to pay attention to detail because it makes a difference. When we start strings, do they start at 0 or 1? Right? How many places does stuff output by default? Okay, so you need to know that type of stuff. You need to know the material well, but if you know that, just pay attention to detail, go step by step like we did for the examples in the class, and you're going to do fine. Yes? Mm-hmm. Mm-hmm. Yep. Uh-huh. Yeah, once you do set precision, it lasts forever. Set width only affects the very next thing, so you have to use set width over and over. Set precision and fixed, once you use them, they're done. They affect everything going on. It affects not only that line, but any other C outs below that until set precision is called again. Okay. Yep. Uh-huh. Does that still set the number of decimal places because the fixed is above it, or does that yes. Set the number of digits? Okay, before fixed is called, set precision display tells you how many total digits to display regardless of where the decimal point is. After fixed is called, any call to set precision affects how many decimals to display. For the rest of the program. Set precision and fixed are forever. Set width is only the very next thing. Uh-huh. Yep. It changes the number of digits you're going to show. Yes. For in numbers, right? For numbers. Other questions? Sir? Yes, the question is, can I explain what fixed does? So by default, when we're printing numbers in C++, it prints 6 digits. And by 6 digits, I mean total numbers before and after the decimal point, right? Set precision says how many numbers to show before and after the decimal point by default. If you include fixed, if you see out fixed at any points, it changes the way set precision works. It no longer says show me this total number of digits. It says show me this many digits after the decimal point, regardless of what's in front of the decimal point. So that's what fixed does. It changes how set precision works. Okay. Yep. Mm-hmm. Sir? Nothing. If you include fixed with set precision just shows you how many things to show after the decimal point. You can have any number of things before the decimal point and it no longer matters. That's after fixed. Before fixed, of course, set precision is the total number of digits to display. Right? Yes? Well, fixed will work on its own because by default, set precision is 6. So by default, it'll show 6 digits. And then if you say fixed, it'll show 6 digits after the decimal. Does that make sense? By default. Yes, you had a question too? Okay. Yes? Mm-hmm. It says go to the next, it says do the next step in the loop. So if you hit continue in a while loop, it just goes back to the top and checks the condition again. Even if there's other statements underneath that. If you hit continue in a for loop, it takes you up to the top of the loop to do it again, but it also does that increment statement before it goes back to the top of the loop. And it's different in a while loop, because in a while loop, if you say continue, it doesn't automatically do any increment statement that you've included below, right? It goes back, so continue just takes you to the next step. In a for loop, it automatically does the increment. Yes? If you have the increment outside of the while loop, the increment's never going to get called because it's not in the body of the loop. So, other questions? Yes? Yes, so the question was if you have a while loop or a for loop and set precision is inside the loop, does it change it outside the loop? Yes, it does. Once you call set precision, it affects every output forever. Just like when cin breaks, once it's broken forever. For cout, once you do set precision or once you do fixed, It changes it forever for the rest of the program, or until the next time set precision is called. Right. Yes? How do you set something equal to a space? You can use a character. You can say char something equal sign assignment equal single quote space equal. Or you can do a string. You can do string space equal double quote space equal. So you can set something equal just by using the assignment for the right type. But you can only do it with strings and characters. And you have to use the right quotes. Double quotes or single quotes. Yes, sir?
So you said that set precision changes stuff for the entire program. So
Until the next time it's called. Yeah.
okay, so that includes other functions within the program.
Anything. Yep. Anything that's output. Once you do set precision, it's there forever. So for example, in the projects where I do math, like the very first thing I do before I do anything else is I say cout set precision to fixed. And I just knock that out once, and then I know that for the rest of my program, the output's going to be 2 points of decimal forever. And you don't even have to output anything. You can just do that once and set it forever, and it's good for the rest of the program if that's how you want your output. Sir? So the question is, does set precision change the way the calculation's done or only the output? The answer is only the output. The calculations inside are still carried out to the fullest extent of the number of bits that we have. And so later, if you've done you can actually calculate something with a lot of decimals, output it with a lot of decimals, change the precision, output it again with just a few, change the precision again, output it with a lot of decimals, and it will always show what it was. So internally, it's always uses as much space as it has. Sir? So the question is, what is an unsigned int? Normally an int has negative numbers and positive numbers. But remember, we're representing these things with bits. And so we can only represent a certain number of, a range of numbers with a certain set of bits. What unsigned means is that there's never going to be any negative numbers. And so instead of running from some negative n to some positive n in terms of range, it's going to go from 0 to 2n, the range of numbers that it represents. You can never have a negative number. And since you're not using what it really comes down to conceptually is since you're not using one bit as a plus or minus sign, you can double the amount of numbers that you can represent. Okay? Yeah. If you couldn't, well, okay. In the practice exam, I had a question where I said unsigned int equals -1. That actually compiles correctly, but it doesn't represent the number correctly. Weird stuff happens with the number. And that was actually something that was, when I write exams, I don't always get all the questions exactly right, and that was one of the ones that I would take back if I had a chance. I gave credit for people whether they said it compiled or whether they said it was wrong. Conceptually, it's wrong, but the compiler accept it, but the compiler probably shouldn't accept it. Because I can talk to you, that comes out essentially a huge number. If you set unsigned n equals -1, it prints out a huge number because of the way it's represented. But that's not something I expect you to know. That was a bad exam question. Bad exam question. What about that? Yeah. And it just sets it equal to 3. Again, conceptually, you found all my bad exam questions, right? That was one I was like, I need some more questions. I only have like 5 more minutes before the exam. I'll just write some stuff. And so it happens, right? I don't want you to, this isn't like, the SAT where before you get the question, there's been 15,000 other students who have tested the question 9 times. I wrote the exam yesterday while I was watching The Walking Dead. So part of it while I was watching The Walking Dead, right? So I wrote the exam. I did my best. There may be some errors on there. We will do our best to live with them, okay? So do your best. That's my. And by the way, if I have a bad exam question, I take responsibility for it. It's not like that was a bad exam question, but you should have known. You should have been psychic. I mean, if it's a bad exam question, I just don't count it in the overall total, or I give you credit for a reasonable score, a reasonable answer. Yes? It will truncate, which means it will just chop off any decimals. It will not do any rounding. So even if you do division and it's like 3.999999 is the answer, it's just going to tell you 3. Yeah. Yep. It will just truncate. Unless you explicitly tell it to round, it will generally just truncate. So, but you notice that I didn't really go into detail over rounding rules and when things round, and the reason is that I actually don't know. It's kind of complex. So I don't expect you to know if I don't know. That's why I don't trust floating point numbers, right? Yes? Yep. So the question was, if you are dividing two integers, but you're using assignment to set that to a floating point, does it do integer or floating point division? Integer. It only looks at the things that are being divided, the top part and the bottom part, which have fancy math names. It only looks at those, and if they are both integers, it does integer division, regardless of where the assignment is going. What is that? The quotient and divisor? Numerator. Thank you. Numerator and denominator. Okay. Yes? That number, the result would be a float, but it would be 0.0 something, right? Because there's not going to be any decimal point. Because when we do integer division, we only get an integer answer. And if you assign that to a float, it just makes it a float, but it doesn't do any of the decimal part. If you had a float and you divided by an integer, you get a float. If any of the numerator or denominator in the division are a float, you're going to get a floating point answer. If you assign that to an int, weird things are going to happen because you're going to lose the decimal part. Okay. Sir? Going back to the thing that I said you didn't have to know, rounding, yes? Sure. No, sometimes. I cannot explain set precision's behavior of what it does to the weird lower order decimal places. So, I mean, probably there's some spec somewhere that I could go look up, but the honest answer is I would rather sit here and say I don't know than go to the trouble of looking it up because it doesn't matter. How's that? Other questions? Yes? So the question is, you have to be able to identify and use literals for each data type. A literal is just a value that a whole value, a concrete value that something can be assigned to. So integers can take numbers without decimals. Float can take decimal numbers. Characters can take things inside single quotes, only one character. Strings can take an arbitrary number of things inside things. Bools can take true or false or 0 and 1, which I had the orders backward there. But. Other questions? The TAs posted some sample questions, by the way. Did you see those? Yeah, they ran them by me. Some of them are evil. But. And there's probably questions in the book. I recommend going through and looking at the book. So. All right, last call for questions. Going once? Going to... Oh, yes, sir. The stuff we're going over today, how much will be on the midterm? 0. But the new material we covered today will not be on the midterm. So the midterm was frozen as of the end of last class. Okay? Some of the material we learned today was on the last sample exam because the last class was a little... I present the material in slightly different order depending on what the projects were. So the last class didn't have vectors. There wasn't a vector exam on that question, was there? On the sample, because we didn't do vectors last semester. We did functions before vectors. This semester we did vectors before functions. So, pardon? Oh, well, I don't know. I don't remember. But I present the material in a slightly different order, and we had a couple of snow days. So, okay. All right. That's it. Everybody's ready for the exam now? Yeah? Because I could just give it to you now. We could knock it out. No? Okay. All right. Wait, last call for questions again? Going once? Going twice? No? All right. I will say that my thought is the exam is not that bad, but I've been doing this for like 30 years. So, all right, last time, what did we talk about? Functions. What is a function? All right, what is a function? Oh, peanut butter cup. I normally eat these myself. Yes, sir. All right, you don't get the peanut butter cup, but here's a piece for trying. Okay, who wants a peanut butter cup? Yes. A sub-algorithm, absolutely. So the idea of a function is it's a sub-algorithm. Instead of having to think of our algorithm as a whole bunch of single steps, we can break our algorithm into a series of smaller steps, each of which has its own sub-algorithm. Okay? And this is essentially called I can't remember. I think it's top-down design, where you think of your big problem and you split it up into small problems, and then each small problem you come up with an algorithm, or you split that up into smaller problems. And as you go along, you come up with these sub-algorithms or functions, and you're able to write and test each one of these separately. How do we get input into our sub-algorithms? Sir? Pardon? Ah, that's for vectors. Pushback is for a vector. That's how we insert things into a data structure. Sir? Uh-huh. And then inside the parentheses we have parameters, and parameters are how, whoa, sorry, that was a horrible throw. The Butterfingers, they have wrapped differently now, and they're really light, and they get away from me. So, okay, so parameters. Parameters are how we pass information into functions. They are how functions get their input. Can functions also get input from the user using CN? How many of y'all think they can? They can, absolutely. Functions can also get information from the user. Output, how do functions, and by output I say, how do they get things back to where it was called from? Yes, from the return statement, okay? We have a return value. It's really light. Sorry. Good catch. Okay, we have a return value, and that tells us what value the whole function takes, right? So the function does some computation, and then that whole expression, what we called function with the parentheses, turns into what the return value was. So, can a function also do cout? Yes, it can, but the caller, in terms of the function that called it, has no idea about that, right? All the place that the function was called sees is that it becomes some value if it has that type of return. All right, so let's just talk about some function stuff then. So here's what we're going to do as an example. I'm going to write a function. We're going to write some functions that allow us to count characters in a string. Okay? So we have a string, and we want to count characters. So here's what we're going to do. If we want to do this right, the first step in our algorithm is ask the user for a string and for the type of character they want to count. Right? So let's say we want to count E's or count A's or X's or something like that. Then what we need to do is actually count the characters, and then we have to output the results. Okay? And what we're going to do as an exercise is write functions for each one of these things. All right? Does that make sense? Everybody good? So here's what the first step is. For the first step, what we're going to do, and there's a lot of different ways we can do this. I'm going to do it a particular way that suits what I want you all to see. What we're going to have in main is we're going to have a string, which is going to be our input. And we're going to have a char, which is what we're seeking for, which we're going to call sought. Okay, so we're going to get a string as input. So the first thing we're going to do here is we're going to display instructions. Now this function display instructions is just going to print what the instructions for this are. Sir? Pound include string? Yeah, I will. Thank you. So string is one of those things that you can sometimes get away with. Here. Because, it's a Butterfinger. I hate these. They fly really funny. Okay. String is one of these things. You should have it there. In the old days, it worked on Mac, but not on CS class to not have pound include string. I think CS class, they've changed the compiler, and now you don't need it on either. You can get away without it, I think, but it's good to have it. All right, so here's our function. We're going to ask a user for a string and a character and display instructions. So here we are. We're just going to display some instructions. If we have a function that displays instructions, what input does it need? What do we need to give it as a parameter? Anything? It does not need anything. What does it going to return? What value is it going to pass back when it's done? Is it going to pass anything back? It is not. It's just going to print something. It's just going to print something. So let's just go down here and we'll write display instructions really fast. And all it's going to do is say, enter a string to search. And a character to search for. Okay? This is all it's going to do is print out those two lines. Instructions. Thank you. I would have gotten there a sec. Okay. Okay. So, what does this return? What does this value, what does this function return? Does it return anything? So, what type does it return if it doesn't return anything? Void. Void is when you return nothing. Can we have a return statement in here? How many of y'all think yes? How many of y'all think no? How many don't know? How many are too worried, busy obsessing about the exam to raise their hands? Okay. The answer is we can have return, we just can't give it a value to return. And this just says, hey, we're done, go back. Okay? So, we have our function, we need our function prototype. So here we go, void display instructions. All right. All right, so this is an example, and the reason I did this is that this is an example of a function that does not take any arguments, it doesn't take any parameters, and it doesn't return anything. Okay, it's a sub-algorithm that does not need any input, and it does not return any output. It is self-sufficient, all on its own. Yes, sir? Excuse me? So in terms of thinking about functions, the input goes into parameters, and our parameter list is empty. That means there's nothing being input, at least passed as a value, and void means it's not returning anything. Okay? We can still do input and output to the screen and keyboard using C in and C out, but in terms of the information that's flowing into the function and the information that's coming back, there is nothing. Okay? Yes? Uh-huh. You have function prototypes? So I actually disagree with the book. I disagree with the book on this. And I disagree with the book because if you put all your functions before main, you can end up with a situation where function A depends on function B, that depends on function C, that depends on function A. And if the compiler is reading those in order, it'll look at function A and go, I don't know about function B. And if you put function B before function A, it'll read function B and goes, I don't know about function C. So if you put function C first, it'll look and goes, well, I don't know about function A. So if you put function A first, you're back at the problem where it doesn't know about B. So they have this thing called circular dependencies, where each function is dependent on the other. And putting the functions at front before main only works if there are no circular dependencies, which is most of our programs, most of them, but it does happen sometimes, okay? And by putting the function prototypes at the front, then we don't have to worry. It takes care of the circular dependency problem. Now, in the programming you're doing now, you're unlikely to run into that. But it does happen. I was working on some code that I was writing for like a pretty big thing, and I'd written like 3,000 lines of code, and then all of a sudden it wouldn't compile, and I was like, what's going on? And it took me like 20 minutes to figure out I had this very complex circular dependency because one thing depended all the way around. And then I ended up having to spend like 3 days rewriting my code to get rid of that. So that was in Java, which is a different set of problems. But anyway, okay, so that's why I recommend you do it different than the book. Okay, so everybody good with this display instructions? Should we run it and see if it works? Seems to be compiling. Okay. And it outputs correctly. So we're happy, right? Okay. So So the next thing, now we're going to do some input. So we'll say get line cin comma input. And then we will do cin into char, into sot. And we should be good. Okay. So now we've done the input and we've gotten the thing we want to read, so we should be okay. Okay. In fact, I'm gonna update our instructions just to make sure they're clear. Okay, so we're going to have one line that's the string, and the next line is going to be the character, and everything will be fine. Everybody with me? Questions? Sir? No, this last, sure, I'll add an line to that. You're right, since we're doing separate lines. That's fine. All right, so we've displayed the instructions. We have good instructions. Everybody's happy. We have some code that will input the string and what we've sought. And you know what I normally like to do after I do this? I always like to do this just because I'm insane. I like to run it once with some extra code just to make sure that we got what we wanted to get on input and make sure input is working. And that way we can then go on. So I added some input just to make sure we're getting what we want. Compile it. It compiles. We run. Okay. We're looking for S's, and it shows me that it did ring. This is the string in S, so our input is working. Everybody happy with that? All right, so now what I normally do is I go back and I just either comment these out because we don't need them as part of the algorithm, or I just delete them, right? As I'm going on, it's okay to put additional code in to test things and then take it out when you don't need it or comment it out. All right, so now we're going to count some characters. And what we're going to need is we're going to need some integer to hold the count. So I'm adding an integer at the top. And down here I will say, write a function. I'm going to say count equals count characters input sought. Everybody good with that? So here's what we're doing. We're writing our own function. It's called count characters. It needs two things to do the work we want it to do, which is the string we want it to look through and the character that we're looking for, right? And when it's done, it's going to tell us something. What is it going to tell us? What is it going to tell us? Yes, sir. Yep, it should return. And where's it going to put those? Yep, through assignment, it's going to use the count variable. Okay? And so that is going to work well. And then we can output it, and we'll work on that next, but let's just go ahead and write this count characters. So let's do our function prototype. What is this count characters going to return? An int, because there are not fractional numbers of letters in something, right? And it has to take two things to work with, which are a string, because that's the string we're going to search through, and a character, which is going to be the thing we're looking for. Okay? So up here in our function prototype, we say, hey, you're going to have a string and a character, and we're going to be fine. And then down here, we have to write the actual the function. We get a string, and we're just going to call this input, and a character, which is going to be sought. These have the same names as the variables in the main function. Are they the same variables? They are not, because the variables, the parameters, are local to just where they are declared. But I'm keeping the name same because it helps us think about it that way, right? Right? You're like, oh, we had some input up here, we have some input down there, character sought. All right, so now how do we count numbers in a string? How do we count characters in a string to see if they're there or not? Pardon? Length? Well, length will tell you how many characters are total in the string, but it won't tell you how many of a particular character you have, right? But length is going to be part of it because we need a a for loop. So now we're looping over the string, one I for every character. And what do we do inside there? Yeah. Yep, we need a counter. Yep. All right, so here's what we do. Pretty much the same thing when we want to operate over a string, when we want to operate over a vector. We have a for loop. It runs from 0 to either, while being less than either length or size. And then we can do things using that counter variable. We say if input at I, which is going to run from 0 to just less than the length of the string, is equal to sot, which is a character. We count it, and when we're done, we return the counter, because that's how many things we counted. Okay. Questions so far? So let's go back up here, and now what I'm going to do up here is I'm just going to put a temporary thing in to figure out what's going on. I'm going to say cout count. And what this is going to do is just going to show us that we got some value back. And we can see if it's the right value or not. All right? And then we'll do some output results. We'll do something a little bit fancier once we've tested to make sure this works. So I compile it. Compiles cleanly. I run it, enter a string to search for. This is a string of S's. We're looking for S's, and it says it found 10. Is that correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that seems to be working. Isn't that good? Everybody say, yay! Okay. All right. You've been sitting too long. You're starting to slump down in your seats and look tired. Stand up, jump up and down, stretch. Yeah, I can go back to the code while we're right here. So do you want to see the function? Is that probably the most useful thing? No, stand up. Come on. You're all sitting down. Stand up, stretch, wake up, get the blood circulating. This is a huge opportunity for you. How many of your professors let you stand up in class? One, this one, me right here, and you're not even taking advantage of it. Particularly that side of the classroom. It's like the rebel side. All right, 30 seconds left. All right, 5 seconds. Ready? Sit down. Okay, welcome back. Does that help? I don't have to give you breaks if you don't want them. How many of you never want breaks again? How many of you want breaks sometimes? Okay, good. Just checking. All right, so here we are. We've tested, we have ask the user for string and character. We have display instructions. We have input. We're able to count. Now we want to output the results. Okay? Who wants to help me through outputting results? Going once. All right, I'll just do it. So here's what we're going to output. We're going to have something called output results. And output results is going to tell us what the string we were searching through was, what letter we were searching for, and how many we found. Okay? What the string was, what letter we were searching for, how many we found. So what parameters does it need? It needs the input string. It needs input, sort, and count. Okay? Does this output results, is it going to return any value? Is it doing any calculations we have to get an answer for? It's not. It's just going to output something. So up here we come out and we say, what is the type if we don't have anything to answer? What is the type if we don't have anything to answer? and it takes a string, a char, and an int. Okay. So we'll go down here, void output results. It takes a string. What do you want to call this? How about input? Is this the same input as elsewhere in the program? Nope, it's not. A char, which was sought. Is this the same sought as elsewhere in the program? Nope. And int count. Is this the same count we had elsewhere in the program? Nope. Each function creates its own special thing. So now we can just do cout. If you can't see, I see people peering around me. It'll be posted online. So. All right, so all we're doing is printing out, the string input had, oh man, what are you? You're like my compiler. Okay. Thank you. Okay, so let's just make sure that compiles now. I think we caught one potential function. All right, it compiles cleanly, and now we should be able to run it, and we'll see what happens. Wait, did I take the old output out? I should have. I did. Okay. All right. Oops, I forgot a space in there, didn't I? Had 5 E characters in it. So I can make my output a little bit nicer, and I can say something like, quote. All right, that's going to be much nicer. Okay, everybody good with that? You can't quite see it, can you? So push it up towards the top. Now, why did we do this? Because I wanted to show you a few things. I wanted to show you a function that had no parameters. I wanted to show you a function that returned nothing, and a functions that in combinations of each. Okay? Everybody good on this? Yes? Questions? Going once? Yes? Sure. Which part? I'm going to post it online. You don't have to write it all down. Sometimes it takes me a day or two if I forget. But all right. I want to show you something that can be problematic. And here's what we're going to do. We are going to reverse our character and our string and our input. Okay? And what we're going to do, so I changed the direction so the character comes first and then the string. And now what I'm going to do is I'm going to change the order of the get line and the cn, okay? What could possibly go wrong with this? Does this look perfectly sane and normal? Should the order matter? I don't even need to change the output because they're being input into the same variables. So, but all I did was change the order that we're reading the character first and then the string. Okay. How many of y'all think this should work just fine? How many of y'all think this should work, but I'm setting a trap because clearly I wouldn't be showing you this if it did work? Okay, yes. So I don't expect this to work, and hopefully it will fail because I want to show you something that goes wrong. So it compiled cleanly, and then we run it. Enter a character to search for. How about an E? Wait a minute. What just happened? Let's try that again. So we run it, enter a character, search for. What character are we going to search for? Somebody name a character? What? Q. I didn't even get a chance to enter my string, did I? It just searched for Q I didn't even get a chance to enter anything else. Something went wrong, didn't it? All right. Anybody have any idea what went wrong? I don't expect you to, but I'm just curious if you do. So here's what happens. When we actually run this program, what's happening is it's saying cin into sort. And what I'm entering for this is Q and then a return, right? I hit return. What's happening is cin is finding the Q and it's putting it in sort, but cin is not doing anything with the return. Okay? The return just stays there because is a return part of a character? It's not. Well, along comes getLine, and getLine says, okay, I have to get line from input, I have to get line from cin, and it looks at the input and it goes, oh, look, there's a return waiting there for me. That means somebody has already hit return and they want to enter a line with nothing in it. Okay? So this is one of the weird cases where getLine and cin don't work well together. Because cin leaves that return after the letter you type, and getLine comes along and sees the return that's left there and thinks somebody already hit enter. And it screws things up. If you encounter this, it's easy to fix, and I'm going to show you how to fix it because you're going to encounter it when you write your next project. You just do something like this. And what this is going to do is going to clear the extra return after the character. Does that make sense? It's going to clear the extra return after the character. So if we run this now, it should work the way we expect. So it compiled well, we'll run it. We want to search for Q, and the name is oh, we didn't do case insensitive search. So it didn't find the capital Q. All right. That worked, and the input worked because we cleared out the garbage in there. So out of all the things I've shown you, this probably has the most relevance on your project in the near future, other than the function stuff. So I just want to make sure I got that. Questions on this? If you get the case where you're entering stuff and if you're like typing in characters and then all of a sudden your program runs off and does weird things by itself, this is probably what's happening, and this is almost certainly the answer. Okay. Questions? Going once? Spaces we don't have a problem with because getLine will so what happens? Actually, that's a good question. Let me comment these out and try something with spaces really fast. This is an experiment. I don't know what's going to happen. So we compile it. There's no garbage collection. If we hit Q, it dies. What happens if we hit Q and a bunch of spaces? Yeah, I'm not sure what's quite going on in there, but it doesn't really make a difference. I mean, we could cheat if we put everything on one line. Right? It sort of works because it's able to figure out what the string is, but that's not the way we want our input to work. So, all right. Questions? Now I know today is not as much fun. I don't have many like game shows and stuff. Sorry about that. Because of the snow day, I didn't actually get to my office in time to prepare that stuff. So it's just me talking, which is almost as bad as death itself, but not quite. All right. Questions? If not, I'm going to move on to another example that will baffle you and delight you. I guarantee it. Who wants to be baffled and delighted? Awesome. Has this been boring? Come on. This is a little dull. I admit it. It's okay. All right. So let's write a new program. And here's our new program. Our new program is going to have a point, a Cartesian point, a point on the Cartesian plane. What do you know about points on the Cartesian plane? They have coordinates. What are their coordinates? Okay. So we're going to have int x coord and int y coord. How's that? And where does this point lie? You want to give it a value? Where's your favorite place to have a point? 0, 0. The origin is most people like it. Okay. All right. Here we are going to now write a new function. Okay. And the new function we're going to call translate. How's that? So we're going to have this function. It's called translate. And what this function is going to do, it's going to move this point 1 over in the x and 1 over in the y. Okay? So every time you translate the point, it's going to move diagonally up and to the right, 1 hop. Does that sound like a pretty easy function to write? How many of y'all think that's pretty easy? Yes? Okay. How many of y'all think this should be pretty easy? We're just adding stuff to a point. So let's just go ahead and write our function. And when we're done, we're going to actually output where the point is. We're going to say this point is at x colon x. And, man, I can't type today. All right. So we have this line. We'll print out where x and y are. Except I need to make that chord, don't I? All right. So let's just make sure this works so far. So far, all we have is an x and y coordinates. We print them out twice. And it should compile. I didn't see anything wrong, but whoever sees things wrong. And we run it. It says, okay, the point's at 0, 0, and then again at 0, 0. Now we want to actually implement this translate function, which will move everything up and to the right 1. Okay? So in our translate function, what do? We have something up here. We say translate. And we give it an int, and it's done. There's our part of our prototype. And then the other part over here, and we just want to make these things move up. So we say x equals x plus 1, y equals y plus 1. Okay. Now here's my question for you. Logically, this makes sense, doesn't it? Everybody good with the logic behind it? All we're doing is moving a point up into the right 1 spot. My question is, how do we get this x and y back? How do we pass these back to where they were called from? Yes? So, the problem we have is that we can only return one thing. We can only return one value. How many values are we trying to work with here? 2 values. So one possibility is we could pack these 2 things into a vector and just pass a vector back, right? Makes perfect sense, and it's logical. In this case, it might even work pretty well because there's only 2 things, and you can remember what's x and y. But you can imagine that functions get arbitrarily big, and that we might have different return types mixed together. And vectors can only handle one return type, and then it gets complex figuring out what's in what space in the vector. So we're not going to use vectors. So how are we going to do this? Any guesses? Any scientific guesses based on the sample question you saw? Yes? We're going to do the and thing. So here's the deal. If you want to return something, from a function, you can only return one thing. However, there is some magic that we can do. And the magic that we can do is this. what we can do is we can put ampersands in front of variables that are on the parameter list, like this. And I think we also have to put them in the prototype. Let me just make sure that works. And here's what's going to happen. Now this function translate, what is this passing back? Nothing. It is returning nothing. But we put these ampersands in front of the variables, and let's see what happens. We are not returning anything. We are doing some math on these variables in the function, but we are not returning anything, and let's see what happens. So it compiles, that's nice. We run it. And you can see x and y changed. X and y changed in this function. And here's why. When you put the ampersand in front of the parameter, it means that any changes that happen to that parameter inside the function also happen to the variable that was passed in as a parameter up above. All right? Before we got to this point, we were working with what were called value parameters. That is, every time we had a parameter, the value was being copied from where it was called from into the parameter in the function, and information was being passed in this way. These parameters, once you put the ampersand in front of them, are known as reference parameters. Reference parameters. And the idea behind reference parameters is any change that happens to the parameter inside the function also happens to the variable that was passed in up above. So let's just show that. Right here, x was x-coord and we saw it was 0, but we put this x-coord into the translate function and it got passed in as x down here. The name changed, but because this ampersand was here, there was a magic link. Okay? A magic link. There's a small army of gnomes that work to carry the values back and forth between x here and x-coord up here. And just like that, down here where there's this ampersand in front of y, anything that's passed into y-coord that gets changed also gets changed back where it was called from. Yes, sir? Well, let's try it and see. So we will take the ampersands back out because we don't like them and we want to verify that they are actually the source of this incredibly powerful magic that's going on. Okay, there's no ampersands. Now we will compile the program. Without ampersands, we will run it. And notice the values did not change this time. X and Y did not change. Even though they were passed in parameters down here and they were changed down here, they did not change back in the main function where they were called from. And they did not change because they are value parameters. And value parameters, the value of x coord, it looks it up and it goes, oh, that's 0, so I will make x 0. And it goes y coord, that's 0, I will make y 0. And there's no change. All the computation down here is just on those. But when the magic ampersands are there, everything is different. When the ampersands are there, it is no longer x and y. It is actually magic links between this x and this x coord and that y coord and y. Any changes that happen to x and y will also happen to x coord and y coord in the main place where they were called from. Okay, lots of questions. Yes?
Does it coordinate because of the position it is within the
Yes, it knows which one is which by their order in the parentheses. So x coord is the first parameter, so it gets put into x down here. Y coord is the second parameter, so it gets put into y down here. And then this magic link between x coord and x and y coord and y is established. Any changes to y happen to y coord. Any changes to x happen to x coord. Okay. Sir? Yes. Yes. We haven't got to that yet. We will. Yep. So other questions? Okay. So this is like a little magic link that happens so that values can change. This lets us give in an arbitrary number of parameters. These parameters list, I think, can be, according to the C-spec, something like 1,023 parameters long. If you wanted, you can have a function that has that many parameters. And you can establish all these links back so that each one of these parameters, if they're changed in the function, also gets changed where it was called from. Everybody kind of understand that? How many of y'all are with me? How many of y'all are against me? How many of y'all think you're ready to do a problem based on this? All right, well, I have some problem practice sheets here, so let's go ahead and do this. And I said that today wasn't going to be any fun, didn't I? All right, so partner up. All right, there's function 3 and function 4. Partner up. One person do function 3, and then in a few minutes we'll talk about it, and then we'll go ahead and do function 4. And then I'll let you reconsider if you have any exam questions that came up during the course of the class. You don't have enough there. Hang on. Still don't have enough. I don't know what's wrong with me today. What? Do you need one more? I'm being stingy with these. Do you need some more over there? Here you go. All right, anybody not get one? Any extras? All right, this isn't something you have to do on your own. Feel free to talk to someone, talk it through, figure out what this does. You are like the quietest class. I cannot get you to talk. I throw candy at you. I let you talk to your neighbors. Rejected. All right, anybody ready to help with function 3 yet? Sir, go ahead.
So you start off with the very top where it's the line, like
Yep.
and so you notice that only the first variable is going to be one that's going to be reflected back into.
Okay, I'm going to echo you, not because you're wrong, but just so it'll end up on the recording, even though you don't. The people on the recording don't always have the sheet. So we have this function at the top. We read, we see void cubed int and comma int, which alerts us to the fact that the first parameter is a what kind of parameter? Reference parameter. Okay, then. Yep. So we're in int main. We get x equals 8, y equals 0. So we now have two ints. Mm-hmm.
And inside that, you get void q, int and q, which is the y variable, and then int z, which is the x variable, which will be 8. So then q would
Yep.
be 8 times 8 times 8, which would be 512.
Okay, so let me just repeat back for you. So for the record, for posterity, so you call the cubed function with y as the first parameter and x as the second parameter. The y parameter gets copied into the reference parameter q. The x value from x gets copied into the value parameter z. We do the calculation z times z times z, which is 8 times 8 times 8, which is 512. And then we assign that to q. But q is a reference parameter which is linked to y. So any changes to q automatically get reflected into y. And so y in the main program is now changed to 512. Yep, so then we return from the cubed function. And we don't return any value because it's void. But when we go to print out x and y, we print out, yep, we print out 8 and 512. All right, questions on that? Everybody good with that? So in this case, we had a function that took two parameters, the parameter x, which is the thing we wanted the cube of, and the parameter y, which we were using instead of a return value. In this case, we just stuck the value in y because it was a reference parameter. The value back in the main program changed, and we're done. Okay. All right, go ahead and do the next function now. Function 4. You all done? You already didn't oh, well, why didn't anybody say anything? Okay, let's go ahead and do function 5 then. Who wants to help me out on this one? 1, 2, 3. Yeah, function 4. Sorry. Anybody help me out with function 4? Go ahead. Uh-huh. Okay, what do we see before int main though? So, oh, I'm looking at the wrong thing. Yeah, so we have function 4, which has void cubed int, and what does that show us in that parameter? A reference parameter, yeah. So we go to int main. X becomes 8, y is 0. We call cubed of x. Yep. 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 So, okay, so cubed of x is 512. X gets linked with the variable q in the cubed function. You do the math. Q times q times q is 512. You set q equal to that. So q is 512 because it's a reference parameter. X is also 512. Go on. Exactly. So when it counts x is 512, y is 0 because it hasn't changed at all, and we're all done. Good job. Questions? Yes, ma'am. So the example of all these functions, if you've noticed, I gave you a sheet last class, and I gave you 2 more, and I'm about to give you 2 more right now, is we're doing the same thing over and over again in different ways, just as an example so that you can see how you can use these things differently to accomplish roughly the same thing. Does that make sense? Now, as to which you choose, if you're actually writing your code, it depends on what you're actually doing. Okay? This is kind of opening your eyes to the possibilities without giving you explicit instruction of what you want to do for a particular case. All right? Does that make sense? Most of the time, you will use reference parameters if you have more than one thing you are trying to work on and pass back. Most of the time. Sometimes, however, you will use a single reference parameter, and there will also be a return code that's like an error message, so you can mix and match these things depending on what you're doing. Just to confuse you. Sir?
You have the and sign in the function after the main, and you forget to put it up top.
I don't know if it'll compile or not without that. We can look and see. I can't remember if they're required in the function prototype. I suspect they are, so we'll just test it and see. Yeah, so this is a complaint that it doesn't have the prototype has to match the declaration in terms of the reference parameters. Yes. No, it wouldn't. You have to have the assignment, right? Q times Q times Q without the assignment in the function in function 4 will not change Q. It does. You need the assignment in order to change it. Okay. All right, now we're getting into the advanced round. Everybody ready? We'll rip through these really fast, and then next class when we come back, we can start talking about exactly how to use these things on our. Oh, actually, next class we'll have the midterm. I think I need more. Uh-oh, sorry. You'll have to pass those over. This row will have to get some from the back. Pass them this way if you have extras. Have extras? Who ended up without them? You passed. Oh, anyone else? Here you go, Lana. You can just have two. You can keep those. Those are your copies. All right. Let's race through these. You have 1 minute to do function 5. It should be easy, right? Do the other one now. Do the one in back. Man. All right, who's going to help me with function 5? Scott Harrington, how about you? Okay, so we look at the top, we see that there's int cubes, it's returning an integer, and it also takes a reference parameter. Int x equals 8, y is equal 0. We do y equal cubed of x. Yep, x is linked to q in that call. Q equals q times q times q, so q comes equal to 512, and then we return what? We return 10. So back at the call where y equals x cubed, what does y become? Y becomes 10, but what happened to x? It became 512. So what is this output? 512 and 10, absolutely. Correct. Okay, go on to number 6. Number 6 is the difficulty that I like to throw on exams, just to throw a wrench into your mental cognition while you're doing problems. All right, who's going to help me with number 6? Go ahead. Uh-huh. Yep, it's the same as function 5. We have essentially the same stuff in there, right? We have a single function that takes a parameter, returns an int. Okay, so in the step inside cubed, we get q times 2 times 2 is 512. We use assignment, which makes q times 512. That is linked to x, so x becomes 512. And then? Yes, so return 10 then, so x becomes 512, but the whole cubed x function returns 10, and then once that returns 10, the assignment into x overwrites the value of 512 and makes x equal to 10. Now, let me ask you a question. Would you ever do this in a real program? Would you ever do it if you were a jerk professor trying to confuse your students on an exam? All right, you have it. Yes, you would. Have a good class. One thing, I will not have office hours today. They will be tomorrow afternoon instead. You should have gotten an email. See you Thursday for the exam.